Okay, let's start with 11.6, similar triangles, page 616 in your book. What is a similar triangle? It's two triangles that have the same shape, but not necessarily the same size. The corresponding angles of the two similar triangles are congruent. This squiggly line right here, a single squiggly line, is the shortcut for writing similar. And that's the congruent sign, equal to, and the squiggly line above it. The corresponding sides of two similar triangles are also proportional. And when I say proportional, I mean they have the same ratio, and you'll see that here in this example right now. Suppose I have two triangles, and I want to just investigate these two triangles and look at them. I notice right away that A, B, C, and D, E, F are kind of the same size, shape, okay? But definitely this one is bigger than this one. This one is smaller. But I then look at the angles. Well, 83 degrees, 56, 56, and the bottom right, 41 and 41. So all the angles are the same. So it must be similar triangles. And then when we look at the sides will be proportional. Let's take a look at that. Here's the corresponding angles. A and C is 56, B and E is 83, C and F is 41. We just looked at that. Now let's look at the sides. Well, AB is corresponding to DE. Okay? So AB and DE are corresponding sides. So if I set up a ratio, put the AB on the top and DE on the bottom, I get a 2. The length of AB over 4, the length of DE. And that reduces down to 1/2. If I then look at the next side, BC and EF, I get 2.5 over 5. 2.5 over 5 reduces down to 1/2. And finally, looking at the bottoms, 3 and 6, 3 over 6 reduces down to 1/2. So in a similar triangle, all the angles that are corresponding are equal, and each of the sides, when set up as a proportion, come out to be the same. All right? Let's look at an example or a problem. What if I was given these two triangles right here, right there? These two triangles. If I've given those two triangles, are these triangles similar? Remember, this is the symbol for similar. Okay? Well, for them to be similar, I need to have all the angles, corresponding angles, be the same. So I'm going to look at it. What is my given? I've got two that are equal here and one number here, so I can figure out those two. And I can figure out, I've got 2, missing 1. I'm going to figure this one out first. Well, P is equal to what? Well, I know two angles, so I know that a triangle has 180 degrees total. And I'm going to subtract 51 and another 51. And what do I end up with? I end up with 78. So angle P right here is 78. Well, that corresponds with an M. Notice I have to rotate this one around to be the same size. That P and M are the corresponding angles. Okay, so now I got to find out if N and O are equal to R and Q. Well, angle N and angle O are both equal to 1/2, because they're the same, of 180, the full triangle, minus the 78. 180 minus 78 is 102. 102 divided by 2 is equal to 51. So I've now proven that N and O are 51 degrees, which matches down here, and 78, P, matches M, and so all my corresponding angles are congruent, are equal, thus these triangles are similar. Okay, let's continue on with example 2. In example 2, we were given two similar triangles. We're told that they're similar, and we're given the fact that they have 47 degrees on the bottom left and 98 degrees on the top. And the smaller one has sides 3, 4, and 6, and the larger one has A and B and 16. And we're told to find A and B. Well, we can use the fact that we know these are similar, and that similar triangles have proportional sides to set up our solution. So if I look at the corresponding sides here, I'll just write them out. I'll put the TU should be corresponding to WX. You see that? TU and WX are corresponding sides. And they should set up a proportional ratio UV to XY. And that should also, the bottom should also come across TV to WY. So those three fractions should all equal each other. And let's now substitute in the actual values. TU is 3 over A. UV is 4. And XY is 16. TV is 6 over WY, which is B. So we're looking for A and B. So we can set this up as two separate problems. The first problem, we'll set up a proportion. 3A equals 4 over 16. We cross multiply, we get A4 is equal to 48. Divide both sides by 4, and we're left with A is equal to 12. So we've just solved for A. Now we can do the same thing using that proportion. We'll do that right here. 4 over 16 is equal to 6 over B. Cross multiply, we get 96 going this way, and coming back this way we get 4B. Divide by 4, and B is equal to 24. And so the two missing parts of this triangle, A and B, are 12 and 24. Okay, let's look at example 2B in your book. In 2B, we have this triangle. And this is kind of a triangle drawing that you'll see a lot in the books. It's one triangle with a small triangle inside of it. Okay? And we'll call this A, B, C, D, and E. And we know that these are both right angles. Okay? And we know that from here to here is 6 long, and from here to here is 9. We know that we want to find X, that outside, and we're given that this is 10, the inside vertical line. Okay, so we're told from this problem, find X. Okay. And one of the things we're given is that triangle ABE is similar to triangle ACD. So this little one is similar to the big one. And right away, we're looking for a side. And since we know they're similar, we can set up a proportion. We know that X over 10, which is the big triangle over the little triangle, is got to be equal to the same proportion as these two bottom numbers. So the big one is 9 over 6. We cross multiply, get 90 equals 6x. Divide both by 6, and we get x equals 15. So we've just solved for x. What would happen if I had done that differently? Let's say I had decided to do the small triangle on the top, and I had said 10 over x. Well, because I did the small triangle on the top, then I have to do the small triangle on the second proportion. So the proportion would be 6 over 9, and you notice you get 6x equals 90 again, and x still equals 15. So as long as you don't mix which order you're doing it, the proportion you set up can be in either format, either big over little or little over big. Okay, as long as you don't mix them up. And finally, let's take a look at a kind of a real-world problem. Let's take a look at a problem where we have Janelle and the Washington Monument. Okay, and Janelle is standing on the sidewalk next to the Washington Monument, and the shadow, she's casting a shadow right here. Okay, and her shadow is 3 feet long, and we know that Janelle is 5.5 feet tall. She's standing next to the Washington Monument. There's the Washington Monument, and it is casting a shadow right there, and its shadow is 302.5 feet long. How tall is the Washington Monument? Well, we know that because everything's happening at the same time, these are similar triangles. So we can set up our proportion. We know that Janelle, 5.5 feet over her corresponding side is x on the Washington Monument. And here, we'll say 3 is her shadow, and the shadow of the Washington Monument is 302.5. Okay, so now what we'll do is cross multiply. We cross this way, we get 3x, and you multiply that times that, you get 166.3.75. Divide both sides by 3, and you get 554.6 feet. And this is not equal, it's approximate. And there we've solved how tall the Washington Monument is by using Janelle's shadow on the sidewalk and measuring the shadow of the Washington Monument.